Day 52 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time it's day 52, guys. We're still going. I hope you guys are feeling good, feeling great, and I hope you don't feel like slowing down because we're not slowing down anytime soon. We're going to keep going. I need you guys to stay motivated with me. You guys help me stay motivated. When I see you guys are watching this page, that motivates me to keep going. So I hope when you guys click my page and see that I did a problem today or every day, I hope that motivates you guys as well, and we can both help motivate each other because yeah, that's what we're supposed to do in this Swift community. You know, we help each other up, help build each other, guys. So with that being said, don't forget, guys, don't forget to bring a mouse, bring a mouse, bring a mouse, bring a mouse, bring it right over here and click that subscribe button for me, guys. Then after you click that subscribe button, go ahead and smash the like button for me. And after you smash that like button, you already know I need you to go ahead and drop one of those bank emojis in the comments. All of my bankers out there, go ahead and drop a bank emoji in the comments so we could go ahead and grow this community the right way, guys. And now, the part you guys have all been waiting for, the question. And the question we have here today is 1,372 longest zigzag path in a binary tree. The difficulty level is medium, but you guys know we're not going to let that stop us. We're still going to do it, and we're still going to keep the solution as simple and easy as possible to understand so that we all can learn and we all can understand what it is we're learning, and so we can carry that knowledge on to the next question that we do tomorrow, guys. So get excited about that. We're in the depth first search part of the binary tree in LeetCode 75. If you're looking for us, we're in the LeetCode. We're doing LeetCode 75, guys. So let's see what the question says. It says you are given the root of a binary tree. A zigzag path for a binary tree is defined as follows. Choose any node in the binary tree and direction, right or left. If the current direction is right, move to the right child of the current node. Otherwise, move to the left child. Change the direction from right to left or from left to right. Repeat the second and third steps until you can't move in the tree. Zigzag length is defined as the number of nodes visited minus 1. A single node has a length of 0. Return the longest zigzag path contained in that tree. So, that question did a pretty good job at explaining it, but in case it didn't, we're trying to find the longest zigzag path, guys. So if you look here, we're looking at the nodes or the values that are in blue, and it goes right, left, right. That's the longest zigzag path. We don't include these nodes that are not white because if you look, this one would go, say we started at the top, the very root node, it'd go right, then it'd go right again. That's not what we want. We could go right, left, however, that would be a zigzag. However, that would not be the longest zigzag. That's not why it's lit up in blue. This would be the longest zigzag, right, left, and then another right. You see, this isn't included in the zigzag, nor is this included in the zigzag because that would be right, right, or if we did it, or this one would be considered right, left, right, right. And we're not considering that. We want a zigzag, so we want the longest right, left, right in that pattern. If we could keep that pattern, we want to see how long we could keep that pattern and which path is the longest of that pattern. So we look down here, okay, well, yeah, this is the input. We kind of just went over it, but yeah, we had the input root. The output is 3 because that's the path. It goes right, left, right. That's 3 different directions it went, and that's why the output is 3. Explanation, the longest zigzag path in blue nodes, right, left, right. So yeah, that's why the output is 3, guys. And I just want to say, guys, if you need help understanding this is the list of the nodes in the tree so you can understand how this works. If you see, it goes 1. First we check the root, it goes, so it'd be 1. But if you come this way, it's nothing there. So that'd be null. It'd be 1, then it'd be null. Then we check this side, it'd be 1 again. Then we check this side, it'd be 1. And we check this side, it'd be 1. Then we come over here, we check this side, null. check this side, null. So it'll be null, null. Then we check this side, come over here, we check this side, it'd be 1, and this side would be 1. So then it'd be another 1, 1. Then we come down here, check this side, go this side, it'd be null. Come this way, it'd be 1. Then we come over, check this side, it'd be null, null. That's why that's like that. Then we come down here, check this one, or we check this one, excuse me, it go null, 1, and that's how you get this input root of this list right here, if you, in case you were wondering. So let's look at the next example and see how this example 2 looks. In this one, the path is a little longer, but it's pretty much the same pattern. It goes left, right, which is why the output would be 4 in this case, because it goes left, right. That pattern continues 4 times. Explanation, here it is. The longest zigzag path in blue nose, left, right. See what I'm saying? It's pretty much, it's the same as the first one. We go here, there's no zigzag after that. We could go left, right. We wouldn't count this one because it go left, right. That's not what we want. We want a zigzag. We want left, right. And that's why the output is 4. And then we have this one, just one node. The output would be 0 because it's not going anywhere. It's just one value and everything else would be null. That's why the output is 0. It's basically like if this was the only one and both of these are null, we wouldn't have nowhere to go, so it would be 0. That's why the output is 0 in example 3. So with that being said, guys, let's get to the solution, the part that we are all waiting to see. So the solution, you guys know, we're going to keep it simple and easy to understand. It's not that hard. And the first thing we're going to do with this, like we did the last few problems, is we are going to create a helper function. So the first thing we're going to do, we're going to say func. We're going to name this function find zigzag distance. And then we're going to create some parameters. It's going to have a root. And that root is going to be a tree node. Then we're also going to want to find the previous left distance. And we are going to set that as an integer. And we also want to find the previous right distance. So we're going to say previous right distance, and we're going to set that to an integer as well. Then we're going to come over here, guys, and the first thing we are going to do is we're going to say guard let root, else we're going to return. Then we're going to come right here and we're going to say first thing we need to do, we need to declare this variable. Up here, we're going to create a variable up here called longest distance, and we're going to set that equal to 0. Then we're going to come down right back in the function we were at, and we're going to say self.longest distance is equal to self.longest distance previous left distance, previous right distance. And what this is going to do, this line right here, is going to return the maximum value out of these 3 parameters right here, out of the longest self.longest distance, previous left distance, or previous right distance. This is going to return whichever one has the maximum value. Then we're going to come down here, we're going to use a little recursion, and we're going to say find zigzag distance, and we're going to pass in the root dot left. Then we're going to say previous right distance plus 1, because remember we're going zigzag, so in order to get to the left, that means we had to increment, we had to start from the right, if that makes any sense. So we're going to increment the right distance right there, and then by 1. Then we're going to come over here and we're going to enter 0, because That's all we're incrementing. We're not incrementing both distances. We're only going to increment the right distance because we want the zigzag pattern. So then we're going to come down here and we're going to do the same thing for the right side, though. We're going to say find zigzag distance. This time we're going to say root dot right. And this time we're not going to increment right here. We're not going to increment the previous right distance. This time we're going to increment the previous left distance plus 1. And then that's all she wrote for that function, guys. Then we're going to come up here and we are going to, we are going to call that function. We're going to call find zigzag distance, and we're going to pass in the root, and we're going to just start them both off at 0. Then we are going to, both the distances we're starting off at 0 because we haven't started. That's just where we're starting from. Then we're going to come down here and we're going to say return longest distance. And guys, that should be it. Let's run it and see how it runs. Hopefully it all goes well. I think it will. Ooh, got a typo. Typo, guys. It's all right. No big deal. Not a hard fix. Nothing we can't solve. Ooh, and it's accepted. Boom. So let's submit it and see what that time is looking like. Let's see. Okay, 223 milliseconds beats 46.53% of users with Swift, guys. Not too shabby at all, guys. So I hope you guys can understand this solution. It's a pretty easy solution to understand. Just remember, we're going to zigzag pattern. So we're only going to increment one at a time. We're not going to increment both of them at the same time because we're going in, we're switching directions every time. Every time it should be a new direction that we're going in. So with that being said, guys, I'll see you guys tomorrow for another day, another LeetCode problem. See you later.